what our units look like. You can see that we've got an arm, so we have a robotic arm. We have the controller back behind here, and then we have the teach pendant. Those are the three main parts of this robot. So let's go on. Here's the teach pendant, and there's a number of keys on here. You can see that I've got an on-off switch over here. We've got an E-stop. Of course, that's going to kill everything if I hit it. So if you think you're running your program or whatever, and it looks like it's going to crash, and you're starting to get a little bit nervous, you can always just hit the E-stop and it'll kill it as well. And then you've got a number of push buttons down here. The big ones are the ones that we're going to use most often would probably be the shift key, the reset, well, just the one that got listed, the coordinate key, our jog keys, and if we play with the speed, we can use these two as well to adjust our speed. Those are the ones that we're going to use most often. And I will give you the opportunity in lab today to even try that if you want. Okay. Our robots are 6-axis robots, meaning that they actually have 6 different joints. You see the joint 1 is right down here by the base of it. Be right here, 2, 3, 4, 5, and then 6 is out here. Okay. When we're dealing with our robot, and working with it and learning how to program it, we're going to use Cartesian coordinates to move it. Does anybody know what Cartesian coordinates, what I'm talking about?
Isn't that just X, Y, and Z?
X, Y, and Z, yeah. And if you look at them here, obviously they're shown. You can see X, both plus and minus, Y, both plus and minus, and Z, both plus and minus. And in this case, they have to have an origin, and it's right here at the base of the robot.
Is that the first joint?
Pardon?
Is that the first joint also?
Yeah, it would be in line with the first joint. Our first joint would be right here, where we actually pivot. And actually, just in case you asked a lot of questions, I brought a little model for you to see too. So here's your first joint. Right at the base. Your second, your third, fourth, fifth, and then this last one, even though you can't see it, is this black piece that turns. So that's your 6th. So you do have 6 joints to that.
Is that a toy or is it?
It's the actual model.
Because that's all the plugs in there.
No, it's not a functional model.
Oh, okay.
No, there's nothing in it. These robots actually work with servo motors. So what's actually making them move are servo motors. And we can actually look at those as well. I've got one with covers off it so you can actually see inside. So Cartesian coordinates, just like you said, X, Y, and Z. So they picked out some numbers here just randomly, and they said, okay, if I'm going to go X 600, which is positive, I go out to here. I've got Y 800, where am I going? Anybody? Which direction am I going with Y 800? Yes, I'm going this way, right? Out to here. And then they got Z, but notice they've got Z as a minus 700, so now we're going down. Where Z is the axis top to bottom. Okay? If you can't remember what is X, what is Y, and what is Z, they have what is called the right hand method. You point your finger straight ahead, that is X. Y is your second finger going off to the side, and Z is your thumb that goes up. All of those are in the positive direction. If you just extend them out the other direction, those would be your negative directions for X, Y, and Z. And if you read here, it says, if not world mode, origin can change. And we'll talk a little bit about that. World mode was where we saw that origin right in the center of the robot. Okay. What they call those are frames. So different frames. Okay, so here, you can see that we got our X, Y, and Z, but notice the origin has changed. It is no longer over here on the base where we saw it before. It has actually been extended out. Okay, so our X, Y, and Z start at this point. So our frame, which would have been over here before, has now been extended out further. You do that by manipulating what your coordinates are. You can actually set the coordinates. So we can say we want to go out so many centimeters out away from the base. That can be our origin.
So you're orienting on what you're working with?
Yep.
More or less?
Say I was going to build a piece of equipment or set a piece of equipment in place, and I'm using my robot to do some welding. Well, what happens if it's sitting like this? If my robot only knows X, Y, and Z, it'd be pretty hard to weld on this at an angle. So we actually go to what's called a user frame, and we would set this up as our origin. We'd have our X, Y, and Z figured out for that. So that's what a frame is. And they actually have different ones that they use. They've got world frame, that's the default one. That's the one that uses the base or the center of the robotic arm as their origin point. And then you've got tool frames, and again, that's going to determine where your tool is actually going to be used. Like when I tip the book up, we would use that for our tool frame origin point. Then you've got user frames. Remote tool center point, that is if we actually had like a welding rod or something on this. So when we go to tool frame, we're talking about this piece right here, the center of this. If we have something that extends out from that, that'd be your remote tool center point. So if it extends out, we would go off that. So there's a lot of different choices we can use. When we get to the lab and you want to play with this, we will put it in world frame. It's the easiest one for us to use at this point. And you can see right here they are showing that the orientation of that world frame, again, our origin point is right here at the base of our robot. And I just mentioned this about the tool frame. If we use that, it's the default of the base plate where we mount our tools on there, on the arm. And if we look at it again, you can see that if I do actually have a tool that extends out past that base plate, then it would be a tool center point that we'd actually be using for origin. Here they're just showing that they can move it or readjust it or change your origin point. And of course, when you do that, we have to determine what that frame would be. So user frames, we can set up just about any way we want. We just have to make sure that we know where that origin is going to be. Okay, now, what we're going to do, and actually I brought in one of the teach pendants with me. When we go into the lab, I'm going to actually have you have the opportunity to move the robot a little bit. We use the teach pendant for that. And you look at your X, Y, Z. These are the three major axes. Okay, that's your right-hand rule. Okay. The orientation or the minor axes are out here, where we have what's called yaw. This is pitch, and then right here at the end of that roll. So those are your three minor axes. Any questions at all? Does that make sense? This is one of our robots that has seen better days. You can replace these pieces to lay over the keys. You can see that we've lost quite a few on this one. they just get brittle and break off after a amount of time. But I wanted to show you that because using this, we got a few things we need to do, but there's something on the back you have to be aware of. That's what's called a dead man switch. So when you're programming the robot, you hear a click. When I pull it and click it, now I can program it. If I let go, the robot will stop. Or if I squeeze hard, the robot will stop. Why do you think that is?
In case you die.
Well, it's possible, but why else?
In case it gets out of control and you basically lose consciousness.
Well, consciousness maybe, but with a lot of people, when you're doing this kind of work, when you're programming something, it starts to look like it's going to crash into something or something is going to go the way you want it to. You might, if you remember, you can go like this and let go, and it will stop the robot. I mean, we could hit the E-stop, we could turn it off. If you turn it off, that ain't going to help. But the E-stop would stop it as well. But we've already got our hand on it.
Yeah, it might be your first reaction is to grip or
Yeah, usually your first reaction is when something's going to happen, you squeeze. That's why it's designed to, if you squeeze, it's going to kill it, or if you release it, it will kill it. It's just like hitting the E-stop. So that's why I brought that along, so you could actually see the dead man switch on there. Okay, here's ours. A little different than the one you got in your hand, that's an older model. And you can see those keys that are missing, those are our X, Y, and Z's, and our shift. Obviously we use those a lot because that's why they got worn out and came off there. So when we want to move the robot, we hold the shift, and if we push plus or minus, X plus, X minus, so it's going to move the arm in the direction we want. So again, the ones that we're looking at here are the shift, our X's, our Y's, our Z's. Those are the ones that are going to give us our major movements of that arm. Okay. They kind of color-coded this, so it kind of helps too, because if you notice, all of these keys are blue. The shift key is blue. So it tells you you've got to have those in combination in order to get that robot arm to move. Okay, so to open a file, we would actually first select, arrow to it, and so on. We'll get back to that, I think. I'll go through this a little bit with you. Okay. So if you look at that, and I think you can still see it up there, I'm not sure, but if not, I'll bring up our teach pendant here, and you can see that I do have a select button right here. Can you see it on that? Does it still exist on that? Okay. So we still have a select button. So if you push the select button, what's going to happen is you're going to get this window to pop up, or the screen will change to this. And what this does is it lists all the programs that are in there, that have been stored in the memory of this arm. The one that's highlighted is the one that I created. We use the letter ZZ when we're creating our name for our program. The reason for that is at the end of the semester, it's easy to go in and get rid of the Z's. Okay. So rather than have this thing get so full of programs that nobody can use it anymore, and how do you determine which ones to get rid of? We've already got them tagged as Z, so we know that those are ones we can get rid of. That's just here. I don't think you're not going to find that every place you go, obviously, but at least here we know which ones are which. So anyway, you would arrow down or up or move to whatever one you wanted to. You can see that mine just happened to be 81 of 84. That right here. F2 to create, we're going to do this today as well. So we're actually going to go in, we're going to move the robot arm around. I'll show you how to do that, and then we'll actually go to and set points inside the work cell so you can see what's going on with that. Okay, you can see here that I've got this picture here because you can see my finger pressing at F2, which corresponds to create. So if you go in there and you want to start with a whole new program, in other words, you don't want to use somebody else's or you don't want to use something unless you got one in there already, then you can, enter that one. But in this case, you want to create a new one, you just push on F2 for create. Okay. And you can see them along the bottom there. These are your actual choices. So when we hit select key, this pops up, and these are the different choices that you can make. And even if you want to go out and delete your program, if you have a program in there to delete. Yeah. When we do go in there and we do click create, you got to create a name. You got to put that in there. And how we do that is this Alpha Unit 1. And even though you can't read it, it says uppercase. Okay, so we'd go in there, we'd actually click on that, and we would type in, let's see what we got. Let's see if I get back to it. I've got to clear one. I thought I did. Okay. We would actually go in there, go to the uppercase, and we would type in whatever it is we want to do. Now, again, you arrow over along the bottom of that row. Again, it's really blurry, which you'll have to excuse me for that. But if you go along this bottom row, we actually have the letters in groups. Okay, so you would find, like over here, I think we got Y and Z. So you go to Z, put a Z in there. So that's the first letter you would place in there. The thing that you have to remember is to use the arrow keys. Do you see the arrow keys in the center of that? Okay. Now, once you put in a letter, you've got an arrow to the right. If you don't, it's going to put another letter right over the top of the one you just put in. Okay, so every time you choose a letter, you've got an arrow over to put the next letter in. Questions about that? Okay. When you do all that, you get all those in there, and you create that instruction set. We actually would then have to go ahead and put in some kind of motion. In other words, we're going to move the robot. You're going to learn to move the robot to different points. But once you get in there, we got to set those points. We got to say, okay, this is point 1, this is point 2, and so on. So what they use are instructions. And they are like motion format here specifies how to control the path of motion to a specified position. Position data teaches the position to which the robot is to move. Now, this works with the frames. Again, which frame are we using? Do you remember? World. So we will be putting these in the world mode. It also determines the feed rate, how fast we want this thing to move. That's what a motion instruction looks like. So these are the things that we need. We need to tell it what format. We need to determine the position data. Now, they've got two choices. You could either move to a point and then set that point. That's what we're going to do. Or you could have a position register. In other words, a register that you created where you already got a position picked out. You just call it that register. And then you go to that. Yes?
Which motion command are you using?
Motion commands are joint, linear, and circular. That's what the JLC stands for.
No, which one will we be using?
Which one will we be using?
Yeah.
We'll just use the joint. It moves faster than linear, and circular requires 3 points for each part of an arc. You gotta have the start, you gotta have the top of the arc, and then where you want to go to. Okay, so the next one over is your feed rate. We will determine how fast we want to go at it. It's at a percentage, so 50%, 100%, whatever we decide there. Then you've got your, it talks about position data. You can see that it's got what there, X, Y, Z, W, P, R, what are all those? Are the points, or the location of your different joints in the robot. X, Y, and Z, and your rest of that on the outside is your yaw, your pitch, and your roll. So your major and your minor axes. So they're telling you where they're located for each point. That isn't something you have to put in there. Okay, that recorder, you can record your point. Okay. And then over here, your position path, they usually refer to this as termination. And it says fine or continuous, and we'll go through that a little bit as well. Okay, remember these three we asked about, joint, linear, and circular? Here are your three choices. In other words, a joint is between two positions from point A to point B, or point 1 to point 2, that type of thing. And in joint, it doesn't necessarily follow a straight line. It can be like a slight arc or whatever it decides is the quickest, easiest path to take to that next point. Linear, it's a definite straight line from one point to the next. And then circular, like I said, you have to specify at least 3 points for that to create an arc. Yes.
Based on our traverse and the various robots we've seen, is joint the most common?
Joint is the fastest.
I mean,
So
in
yes.
the industry, like the
Yes, so that would be the quickest way to get from one point to another. The only time you would not use it is if you were concerned about any obstruction you might have in your workpiece. In other words, you don't want to crash it going from one direction to another. So if it was linear, it's going to go straight and back. If it's joint, it might curve as it goes over. So if you got a tight area that you have to go in, you definitely want to have linear to make it from one point to the next.
You don't want your robot to be zero sign, do you?
Well, you probably don't want to damage your robot. They do have a little bit of a price tag that goes with it. Okay, so it's always long or about all the axes. And here's the part that's not linear. In other words, it will arc a little bit from one point to the next. Okay, and they don't control. Excuse me, that too. Okay, so here is what I wanted to show you. You can see it's going from point 1, and here is what they've got listed for point 1 for that motion command. Here is going to point 2, and that is the motion command for there. Even though it's fine, which means it's going from this point to this point, you can see that there is an arc. Okay, go from one point to the next. We'll talk about fine and continuous, so kind of keep that in mind that I did say fine at this point. Fine means it's going to go from one point to the next point without skipping or just going around the point. When we go to continuous, that does change. Okay. Linear motion. Speed must be chosen from millimeters per second, centimeters per minute, and inches per minute. In other words, we have to choose the speed. Attitude of the tool being moved is controlled by the attitude at a start point from the attitude at a target point. In other words, it's going to keep it in a tight. Think of welding. If I'm welding something, I don't want the point going up and down. I want to keep it right where I want it as it moves. With the other one, it wouldn't do that. Circular is going to kind of go around and the point will go up, come back down as it does that slightly. So that's what they're talking about there. There's different speeds. Is that the same one? I gotta get it twice, I guess. Okay, so here is your linear motion. Again, we're using fine for termination. Here we had a percentage of our speed. Here we're actually giving it a specific 500 millimeters per second. We're talking a specific amount of speed that we want to use. And notice that line is extremely straight. It doesn't vary or arc at all. That's slower than the joint mode. It has to take a little more time to get where it needs to go.
Probably has to manipulate all through joints or more while it's doing
Well,
it.
it could be manipulate all 6.
Yeah.
Okay, circular motion. Okay, and they say that you've got a starting point and ending point, just like the other two did. But in this case, you have to have a passing point, or you've got to have that part that is going to be your arc. And again, we would have to determine or set the speed that we want. And to create that arc, we've got C for circular, we've got our time, and you can see that it is actually arcing from point 1 to point 3, which is where we wanted to get to. Make sense? And you see that they had to put, point 1 was already determined right here, but then they had to put circular, and they had to actually put a point 2 in there plus a point 3. So they had to have all three. Okay, remember I mentioned find? Here's where find and continuous come into play. If it's at a find position path, robots stop at a point before moving to the next point. And you can see here the instruction. If it's continuous, it doesn't necessarily stop exactly at the point. It's going to get close to it and then go to the next point. In other words, it's going from, say you created want to outline this book. Okay? So this is point 1, this is point 2, 3, 4, and we put a 5 in there just to get back where it's supposed to be. As our robot comes here and it gets closer, depending on what I want that continuous to be, it could skip all the points as it goes around until its final point that it comes to. In other words, it's going to come close to it, but it isn't necessarily going to come here and stop at it. And again, that speeds up the process if you don't need it to be exact. Okay, so that's what they're talking about, continuous. Trying to remember, I think a continuous of, I'll just let that probably show us here.
I presume that's another way to avoid obstacles. That's a little bit more.
If it's fine, we're definitely, and here they've got both of them shown. If it's fine, it goes directly from one spot to the next spot to the next spot. If it is continuous 0, it's pretty close to my fine. In other words, it hasn't varied too much for that. But if I get all the way down to 100, and this can be a 0 to 100 that you can put in for continuous. If I get to 100, you notice that it's quite a ways from this point. Not even close there. It will finally end up where you need it to be. But anything in between, and I don't know if those are supposed to be oil drums or something, it would have a real problem. Okay, if we crash and run through all that rather than going around it. So again, it speeds up the process if it doesn't have to be tight tolerances. If I need to go from here to here and I don't care how to get there, nothing's going to be in the way, I can do that. Right. So 100 is your largest discrepancy, whereas 0 would be your closest find on that. Here they show another example of it. You can see that they're going between point 1 to point 3, and you can see how fine is right to the point, and of course the other ones vary further out as you increase that number. Okay, here is the teach pendant screen. If you look up here, you can see that I've got the selector switch in the on position. I also have my e-stop out. You will notice that it says fault up here. At this point, it doesn't matter during this process of creating the points. Once I try to move the robot, obviously I have to get rid of the faults. But the first thing I want you to see is, you can see right here is that gray bar I was talking about, and it is split into 5 choices, and the one we are concerned with is the one that says create here. They correspond to the F keys that are located down here. So create corresponds to F2, so I'm going to push that. Okay, here is your create teach pendant program, and now it's waiting for me to create the program name. If you look at this little window that popped up over here, this is what I was talking about as far as the alpha input, and you can see the first one that's highlighted says words. I'm going to arrow down, so I'm going to go down to my screen here, arrow down, and you can see now it's switch to uppercase. And now if you look at that gray bar, you can see that the corresponding F keys correspond to a group of letters. Again, for here at our school, we always start with Z's. So there's the first Z, you arrow over. And I'm going to put another one in there, arrow over. I'm going to put a third one in there just so that it isn't going to be confused with another program that I've got in there. And now I'm going to put my initials in there. My first letter would be a G. There's my G. And again, you have to arrow over each time. Otherwise, it doesn't move. You'd just be writing over the top of what you've already created. And then my last initial starts with a J. So I've got my J in there. So now I've got triple Z, G, J. And I'm going to push the Enter key. Okay, if you can see that it changed, that window disappeared. It says create teach pendant program. There's the program name I created. Now it says that the end is highlighted, and this is where you hit enter. Okay, you can see that it now says end here, and it says point. The other one that I couldn't remember before just says touch up. We're only concerned with the point right now. So I'm going to push F1 to correspond with point. And here's the default motion window I said that pops up. And you can see I've already got the second one highlighted. And that's where I wrote down JP with brackets 40% and continuous 100. So I'm going to hit enter. Okay, so that would be my first point. And that would be where you would have your robot positioned. So now, each time I move the robot to a new position, I hit point. Again, the window pops up. I just hit enter. And I will put in all 4 of my points that way, but I have to obviously move the robot to different positions as I do that. So at this point, that's what you're looking at. And when I'm all done, I can go back and I can change these if I need to. Okay? So now what I'm going to do is I'm going to pause the camera, and we're going to go to the robot, and I'm going to run the program. Okay, so here I've placed all the points in. Now you'll notice that it's a gray foam block in the window that the robot's actually going to go from corner to corner on. But if you look here at my screen, I actually have 5 points that I've created. So what I did was I completed the last one and brought it back more or less to my first point. Okay, so that's what you're looking at here. Notice that the robot is in world mode. Okay, so X, Y, and Z. And my faults, I've cleared those now so that I can actually make the robot run. And one of the things we want to do, if you look right up here, you can see where it says step and it's in green. I'm actually going to push the step button here, and notice that I got 2 little red bars and a couple of arrows there now. What that does is it allows me to move the robot 1 point at a time, and we're going to try that. So I'm going to push the shift button and the forward button, and I watch the robot now. Okay, so right now that's point 1. It's going to be moving to point 2, and I just sped it up a little bit. Okay, so there it's moved. I'm going to go to the next point that I've programmed. The next one. Okay, and that would have been point 4, and now we're going to go back more or less to our starting position, so this is point 5. Okay, so now if you go back to the screen where I've got yellow and I've got the 2 red bars and arrows, I'm going to push step again. You can see that it's now switched back to green up here. And now if you watch the robot, when I push the forward button, it's going to go, when I push this, it should run the whole program. So it's going to go through each one of the points that I've programmed. So you can see that, again, every time I push the forward, it's going to run through the all the points that I've actually programmed. All you have to do is hold the shift key. If at any time you think something is going wrong or it looks like you're going to crash into something, you can either take your thumb off the shift button or release or squeeze the dead man switch. So the first thing you want to do when you get over here is we want to make sure our controller is on and doing what we need it to be in. So it has to be on. Our key switch has to be in T or teach mode. We don't have to worry about the green button, but we do want to reset our E-stop. When we get done with it, we'll hit the E-stop and shut it down. Next thing over here, we have an E-stop here that we have to reset, and we also turn the teach pin on. Okay. Now, what mode is this in? When you look right here, see where it says tool? We want to change that. So how we change that is we push the coordinate key. See, it just changed. Now it says user, joint, jog frame, and now we're on roll. Remember, that's where we want to be. Okay, so that's using the robot as our origin. Next thing is we have a fault. Well, I'm not holding this dead man switch, so I'm going to hold the dead man switch now. And right here it says reset. I push that, you see it disappeared there, and it disappeared there. See all that? You're the one that wants to run it, so you're paying attention? Okay, so I got rid of the fault. Now, what we want to do is what? Do you remember? Okay, and how are we going to do that? Good. So we push select, create.
I was right.
Okay. So here's that part of it. And where do we go here? Uppercase. So we're going to arrow down to that. And you can see here's where all the letters showed up. Remember that blurry picture that we couldn't read? Okay, so go ahead and grab it. You got it? Okay. Now you don't have to hold the shift when we're doing this part of it, but you do have to put in a name. Whatever starts with a Z is fine. Keep it in uppercase. No?
Try how to get to this.
We don't want to go to detail. Okay, so you're going to go to create. Okay. We want it in uppercase. And let's see, we want to Z. Okay. And again, if I don't arrow over, I'm going to write right over with the Z that I had. Z. And let's see. Ian starts with an I, doesn't it?
Yeah.
Okay. And what's your last initial?
E.
Say it again?
E.
E? Okay, so that's the first one. We just keep turning that to there. Okay. So once you get all that, now we're going to hit enter. Okay. Notice that's where you had detail and edit before and you couldn't figure out what we're doing. You actually have created the program name now, and you have to hit enter again to get us to the point. That was the only part that you had kind of caught up on. Okay, you want to try it?
Yeah.
Okay, so now he's got the dead man switch. I can release it. Now what we're going to do is we have to move the robot. So hold the shift. Now, again, we're in world mode, so X plus is going to take you this way. X minus is going to pull it back. And why don't you put the points for the gray square around it? In other words, go to that far corner over there and make that your first point. Let's speed it up a bit. You're only at 10%. Better not try it. Now, if you didn't see what I was doing, the percentage keys over here for speed, I sped it up. He was moving very, very slowly at 10%. It'll take us another 2 hours to do this. So he's just moving it into position. Once he's got it there, bring it right down to the foam rubber. Okay. And that looks good. Now what we want to do is push F1. Okay. Now it put in an instruction. Now we're probably going to want to go in and edit. Okay, but right now we'll just leave it. Now move it to our second point, which would be that other corner there. Okay, so how are we going to, yep, there we go. Okay, and just hit point. Each time you hit point, it's going to record whatever position it's in. And that's what he's creating right up here. And if you look at that, you can see that the reason it's coming up the way it is with the speeds and everything else is because these are being recorded in linear mode. If we didn't record it in linear mode, if we recorded it in joint mode, you wouldn't see it. It would give you a different list of instructions. 5? Okay, so he's got all 5 in there. And what we're going to do is now that he's got it, we want to see this thing run, right? Okay, but we don't trust you. Or I should say we don't trust ourselves when we do this. So what we want to do is we want to go ahead and do it one step at a time. Because if it's going to crash, we want it just to be able for us to stop it before it goes any crazier. So what you're going to do is you're going to push that button there that says step. And notice it changed right up here. It was green before. Now it's yellow with 2 little red lines and a couple arrows on it. What that means is each time he now goes through the shift and the forward button, he'll push those together, it'll move just one step at a time or go to one point at a time. So hold the shift and you can, or we can just start where you're at. Let's try what? Either way. He asked, do I want to bring it back up here? Because right now we're on the 5th point.
Oh, okay.
Okay, so he could arrow up and bring us right up to the top, or if he were to just hit the shift and the forward, it would go to the first point, and then the second point, and so on. Okay, so go ahead and hold shift and push forward. And we might want to speed it up.
15 millimeters per second, it will be here forever.
See, it's not very, very fast at all. It's fast. Does it give me any more speed? No, it doesn't give me any more speed. Kind of slow. And I can show you how to change that as well. You can see it's going in a nice straight line because of the missing line.
Which is good because there's a box there.
Pardon?
Which is good because there's a box there.
Yeah, if we were actually in joint mode, I don't think it would arc enough to eat that, but it could be a possibility, especially if it's closer to an edge. Take it through the rest of it.
So what are those black tubes on the arm of the robot? Are those pneumatic tubes or something?
Yeah, those are pneumatic tubes, and what they are is those jaws are pneumatically operated to open and close.
Okay.
Is there a setting to open them on this?
Say that again?
Is there a setting to open and close them on this?
Yes, you can set it up for that. Yep.
So the pneumatics would be used for tool operations then?
It definitely can be, yes, depending on what you need it to do. If you look at the robot to your left, you can see that they're using a vacuum with those little suction cups. That's what they grab parts with.
Okay.
So again, they're using pneumatics to run through that vacuum. And then he's going one step at a time. Obviously, this is going to take a while. We can make changes to that, but the biggest thing that you want to be aware of in linear mode is that it is going to be a straight line from one point to the next. Do you have math today or don't you?
I
You don't.
We do.
Charles
You do? Okay, I'm going to cut it short after he brings it